Welcome, everybody. Thanks for attending the Lunch and Learn, focusing on the lunch, not the learning part for now. My name is Jurgens. I'm a cloud solutions architect at Microsoft. Prior to that, head of AI analytics at a consulting firm. And then prior to that, I'm not going to bore you too much with the details. Personal interests are AI and AI interests for enterprise. So to that point, I don't know if you saw the invite, but I am also busy with a PhD related to AI. So now the next logical question is if we're talking AI, why am I doing this with you guys? Why are we looking at data analytics? And why am I not doing something fun with you guys like AI? And I'm hoping everybody online and in the room has heard of ChatGPT. If you have not heard of ChatGPT, I think the exits are that way. So please just go sit outside for a bit. Guys, there's a very specific reason I am actually not doing that today with you, okay? It's a journey. AI is a journey, and that journey starts with anybody. It's not a rhetorical question. Exactly. AI starts with data. Even ChatGPT starts with data, okay? Even the fun part online, the one you can go and ask it to tell you jokes and all basically a bit of nonsense, even that is based on data. So we first need to get this right before we can have any other conversations on that. So maybe if you guys are enjoying this type of exercises, and I'll talk to Suleiman next time, let's have a fun day on OpenAI. So obviously in Azure, we have our OpenAI services. Part of that forms GPT-3, Dale, and Codex. And I don't know if some of you have actually used Codex before, or Copilot, GitHub Copilot, but we'll dive into those. But I think for this audience, that might be really worthwhile going into it. But that being said, let's talk Data Lakehouse analytics in Azure, okay? And we're going to do this via Databricks today, okay? Who knows what Databricks is at this point in their lives? Shame. Okay, so Azure Databricks is a first-party servicing on Azure, okay? So what does that mean? It means it is not being developed by, it's not a Microsoft developed technology, okay? It has been developed by the guys that actually brought us Spark technology. So everybody familiar with the concept of Spark technology? It's not when you put your finger in the plug and it makes a little spark. That's not the Spark I'm referring to. It's a distributed compute technology. Same guys that wrote Spark thought about Databricks, okay? So we are offering Databricks in Azure as a first line offering, okay? As you can see from my slide, there's a lot of benefits to it. Obviously, we have, with the guys from Databricks, integrated this seamlessly into the Azure environment, okay? But there's something else. So unfortunately, I have seen an AWS badge here and there, nothing against them. Why you can have Azure Databricks on AWS. That's fine. You can do that. But there is a difference. Okay. What is the difference between Azure Databricks and AWS Databricks? Okay. Azure Databricks was built ground up with Microsoft and Databricks to integrate seamlessly. AWS Databricks works a bit differently, just spins up vanilla containers, and then you go from there. It is not a fully integrated solution like Azure Databricks is, okay? But that is just a bit of a quick intro to it in Azure. Now, if we look at Databricks, if somebody asks you, how do you describe Databricks after today's session? All you need to know, it's a unified analytical platform. If that's what you remember, that's it. Then I'm happy for the day, and then we can all go home. Okay. That analytical platform offers us the following options. Okay. You can see here, let me just quickly see. Okay, it looks good from that side. So I just want to, if we look here, we have the ability to do data engineering. Data scientists put up their hands. Okay, data engineers, hands. Oh, that's so sad. Business analysts. There we go. Everybody has a playground within Databricks, okay? But the nice thing about the fact that each of us has a playground, it is still collaborative, okay? So we can still work together, although each of us plays in our own sandpit, okay? Now, the question is, what is the benefit about this Databricks, which is built on top of Spark? Okay, like I said, Spark is a distributed technology. So if you think about the concept of a cluster, okay, I'm not talking about the clusters you have for breakfast, compute clusters, okay? Head node, driver node, worker nodes. So your API scripts or notebooks engage with the driver node. The driver node distributes your workload across different computes to increase performance, okay? So that is the benefit of it. It's a computationally parallel process. So each workload server gets a small piece of the work and then it consolidates. Yes, does make life a bit more difficult. If you think of anybody works in Python data frames before, pure pandas data frames, okay? If you know pandas data frames, if you read a pandas data frame, that is in memory, whole frame, everything, one place, one memory, okay? Great. You can do quite easily a column-based calculation on that. Databricks, you can do it, but it's a bit more confusing because you need to think about the fact that not all of your data will reside in the same place. So if you're going to say, I'm going to use a simple example, average, though you don't have to write your own function to do an average of a column, it's already there for you. So don't do that. I'm just using it as an example. If you take an average on a pandas data frame, it takes the whole table in consideration. If you're going to do it by pandas on, well, not PySpark, it's going to do an average of averages because it's going to take the average of each driver and do the average of averages, which is not going to be correct, okay? Then we don't do averages of averages. So there are ways around it, but that becomes a bit more technical and beyond the scheduling, the conversation I want to have today with you guys. Okay, just a few things, but we'll dive into some of the technical stuff as we go on with this learning journey. Today, let's just do some high-level stuff. Okay, so from a production state, because why is this important? Why am I emphasizing deployment production workloads? Well, it's sad to say, but a recent publication by people way smarter than I am actually have deduced that 7 out of 10 AI projects fail at production state, okay? Because we build Python models on laptops, and then we have no idea how to get that thing into production. Then everybody starts running around, spinning up Docker containers and trying to use flasks, which is slow. It's just a nightmare, okay? So this helps us to get things into production. So we have pipelines and stages, we have job schedulers. This all applies to SQL, data engineering, and machine learning. All this helps us to get into that whole productionized state quickly and easily and efficiently, okay? So just a few things to look at when you start your journey with Azure Databricks. From a data engineering perspective, very similar things you might use. So I know some of the Azure tech is a bit new to you. So Azure Data Factory, that is our technology which loads, transforms data, okay? Quick and easy. That's a quick and easy way of explaining it. Low code, no code, very code-based. Depends on your preference. Nice thing about Data Factory, has a lot of connectors for on-prem systems, cloud systems. You don't have to go build your connectors from scratch. It's there for you. Power BI, analytical BI tool, enterprise scale, Synapse, SQL warehousing, and then our data lake storage. Think S3 bucket on steroids. Okay. From our data science perspective, ML flow. So what does ML flow do for the data scientists' perspectives? That is to make sure you keep track of your experiments, because what happens when we start building AI models, we get our data set, we look at it, we play around with it, okay? And then we start building models and we start looking at the parameters our models are spitting out for us. Confidence levels. I want to say accuracy, but accuracy is not the best way to evaluate a model at all. Okay, if you're only looking at accuracy to evaluate a model, think again, not going to work. Okay, so rather than trying to remember 2 models ago, I had an R of this and a probability of that, and writing it on a piece of paper and losing that sticky note somewhere, ML Flow tracks each run and changes you've made to your data set and to your model so that you can revert back if you are going in the opposite direction of good. Okay, so it helps you keep track of where your model is and how it's performing. Okay, Azure Machine Learning, it's our bespoke technology for building AI models. When it comes to the Azure AI world, it's quite large. We have our scenario where you can build your bespoke models, and we have services you can just spin up and utilize, okay? Like computer vision. Why rewrite computer vision? A lot of people have done it. It's been done. We don't have to prove it anymore. Use the services, get to business value, okay? Then you don't have to learn a whole bunch of things you need to learn again. Everything you know, scikit-learn, TensorFlow, PyTorch, everything still functional within Databricks. Okay, all good. And we can see here, optimized with our Spark. So it's not vanilla Spark, like I've said before. And something new to the table is Delta Lake. Okay, so please don't confuse Data Lake with Delta Lake. Okay, so what's Delta Lake? It's not the change in data, something a bit different. Okay, so before we get into that, any questions on Databricks at this point in time? If you don't have anything and you don't want to ask now, you always reach me afterwards. Okay, so I'm going to take you back in time a bit. Why did I show you Databricks? Okay, but first let's do a bit of time travel. Okay, so late 1980s. Yeah, some of us were born before in that time, some of us not. So let's move over that part, okay? So for those of you that weren't there, so this is what the world looked like at that stage. Our traditional data warehouse. Enterprise stagings, the mess, okay? Then the late 2000s, somebody came up with this whole idea of a data lake. There we had stuff like Hadoops, Hives, all that fun stuff, okay? Okay, what was the big difference between these 2 stages in our lives, okay? Rather than learning new technologies other than SQL, it was the beginning of the separation of compute and storage. And that is where the beauty lies in this, is where that journey started. And that's sometimes overlooked. But that is where we started separating compute and storage from each other, okay? Then 2010s, we started this whole idea of a data lake. So you can see here, we have our enterprise data lake where we had our raw layer, which say silver and gold layer. We from Microsoft refer to the medallion data lake architecture being bronze, silver, gold. So bronze being as raw as it is from source, source being anything you can think about it, on-prem, cloud, IoT, as such. Silver, we've done a bit of data quality checking, maybe a bit of aggregation, depending on what we're looking at. And then gold will be enterprise ready state, okay? But now we're at the next phase of this journey, and that is called the Lakehouse methodology, okay? So it should seem very obvious what the definition of a lake house would be. A lake house is obviously let's skip these, I've spoken about this. The lake house takes the scalability of a data lake, okay, as well as the structured and processing power associated with a warehouse and combines the two. That's as easy as it is, okay? So think data lake. The process of a data lake is large volumes of data, generally in Parquet formats. No CSVs, please. Just hard no. Parquet formats. The problem with a Parquet format is who's familiar with a Parquet format? Other than that desk there. Oh. So for those that aren't familiar with a Parquet format, it's generally comes from the Spark technology background, but it is optimized for distribution technologies. Okay, so generally, rather than having one big file, you'll have partitioned files based on how you've decided to partition it, or you've decided the system partition it. So each file is a small chunk of data. So we work in Parquets rather than big CSVs. It just makes life easier for us. Okay, but now think about it. If you have 1,000 small files, okay, and I tell you, go update the following record for me, what are you going to do? Quite easy. You just run out the door and you make it somebody else's problem. That's the best option, I think. Okay. Where in the data warehouse, you write your update statement or insert statement or whatever you want to do. Okay. The Lakehouse takes those two together. Okay. Gives us the power of both worlds. And the other thing is data lakes are cheap. Warehouses tend to be more on the pricey side of things. So now we can have cheap, big warehouses. Okay. Now, how do we do this? How do we get to this point? And this is where the Delta Lake technology comes into play. Okay. So the Delta Lake is a file format based on the Apache Parquet file format. Okay. And we know Parquet is a columnar data store and takes advantage of compression and all that. I'm not going to go into too much technical detail. You can see it on my slide. Okay. The thing is, what Delta Lake does is the following, and this is what I want you to know, is it's an open source format and it brings the ability for asset, okay, not that asset, data asset, okay, to our data lake files, okay? So full asset transactions, allows us to do update, deletes, and merges into our data lake, okay, via Delta Lake format. It also enables us to do something called time travel, okay, because it creates a metadata store for us, so we can time travel back. I'll show you some of this in a bit in real life. You can see what it actually looks like. But this is what's enabling the Lakehouse methodology, is the Spark Apache technology called Delta Lake, which we apply to our data lake so that we have asset and update, delete, and merge capabilities in our data lake. Okay. So within the Databricks Lakehouse architecture, life looks as follows. Okay. So we have our raw data at the bottom. Okay. Structured, semi-structured, unstructured. Okay. We landed in our Gen 2, Azure Gen 2 data lake, okay, in either the landing zone or the bronze, depending on what tickles your fancy. Now, I'm not going to be too worried about it. As long as you land a lot of data in Azure data lake, I'm happy, to be honest, okay? Within that layer, now you can start doing, on top of it, you put your Delta Lake technology, and this allows you to do data engineering, real-time processing as well. So Databricks has its own Spark technology for real-time processing. Okay, so quick solutioning. IoT device, okay, So your IoT messaging broker needs to send a message somewhere. So it sends it to IoT Hub in Azure. And you tell Databricks streaming services to pick up the IoT service. And you start working with your real-time data within Databricks. Then you can land it either in the bronze layer, or you can already start doing your transformations and then do whatever you want to do with your IoT devices. Okay. Data science, machine learning, all on top of your curated data lake. Okay. So either via Databricks, Azure machine learning. Okay. Then our SQL-based analytics, either via Synapse or something new called Databricks SQL. Okay. Databricks SQL, I think the best thing is sliced bread. Okay. My opinion. Then obviously our enterprise BI solutions, obviously this is where Synapse data warehousing becomes a big thing if we do enterprising. So obviously no code, low code, where we have high concurrency, low latency is our Synapse. Okay, why am I saying this? Okay, I know it's a lot of stuff I'm putting in, but everything in Azure is made to work together for value add. Okay, so just a quick side note. So let's quickly segue and then we'll get back to Databricks. Synapse SQL is a bit of a different SQL because it's also a distributed SQL. Okay, very similar to what Spark technology is. Your SQL server is not one server anymore. It's now split again with a driver, multiple worker nodes, and your data itself is also separated from the computes. Okay, so that's the beauty of Synapse SQL. It's a distributed SQL. So it's meant for large SQL databases, okay? And then we can do ad hoc stuff, whatever we feel like in terms of reporting as well. But I haven't had time to put that on my slide, or I haven't been bothered, depending on what you want to interpret it. But Databricks also has the ability to do dashboarding as well, okay? I would not say it is enterprise grade reporting, but it's not bad actually. Not bad at all, but it's not enterprise. That is where we refer back to Power BI, okay? So now Azure Databricks SQL, okay? So how does this differ? So I've already spoken about the data engineering part, the machine learning part. So where does the SQL part come into play? To understand why Databricks SQL is now something different than our data engineering and ML composition, we need to dive into how this works. So if you look at Databricks, and I'll show you this, you can code in multitudes of languages. SQL, Python, Scala, R, okay? But what it does is if you type something like Python, there's a translational layer that translates that into Scala for you, and then translates that into your distributed code, okay? So you are actually, if you're doing Python or anything like that, you are actually just giving it commands, and that's translated by the API layer, and then that executes against your cluster, okay? The SQL, Databricks SQL side is pure SQL. There's no API translational layer involved in it. You write your SQL query, it gets executed like SQL, okay? But the beauty of it, it gets executed against your data lake, okay? So you register a table in Databricks SQL as a table, but it is still a parquet, okay? So you can query your data lake via SQL, okay? So typical SQL commands, select star from table, crashing whole system. Just joking, it won't actually do that. But it is specific for SQL workloads, specific for our guys that want to do SQL analytics. The beauty of it, it is serverless. And there's a serverless option, or there's an easy option to it. T-shirt sizing, small, medium, large, extra large, extra large. Where Spark clusters does become a bit of a tricky scenario to spin up, okay? And I'll show you what that takes and what's involved in that. The SQL server is purely there for SQL workloads. Okay. You can see here from my screenshot, it's your typical SQL-like environment. Okay, so those of you that have worked in anything like SQL Management Studios, there's a specific look and feel that our SQL engineers like to use, where the other part of Databricks is very notebook-based. So think Jupyter notebooks, so cells of executable code, where this looks more like a SQL editor, as you can see here with your tables like the side, and it even allows you to do visualizations without writing a visualization, okay? Those of you that ever have written a matplotlib visualization, you can appreciate this as well, okay? So the other good thing about this, it also provides a SQL endpoint. So what is the benefit of the SQL endpoint? Easily, remember, we want to make everything seamlessly integrate. So if you have a serverless endpoint, you point your Power BI, I should probably say this, but I don't want to say it, but basically any reporting technology you want to use, okay? Power BI, I think there's something called Click and Tableau and all those other ones. You point to your SQL endpoint and you still execute against your data lake, but now you're building enterprise level BI reports against your data lake, okay? So the endpoints are also something that is really valuable when it comes to Databricks SQL. And that applies to the serverless as well as the non-serverless functions. Just remember one thing, if the SQL server is off, don't expect that Power BI reports to work with this. Okay? I know it's like, that makes sense. Trust me, I've seen people switch off this and then wondering why the Power BI reports won't refresh. So it happens, please just note that. And why is that important? Because with all Databricks services, you can have an infrequent termination time on that, meaning it says if no query has executed against any Databricks compute, just switch it off. Okay, so just note that. It is nice because it's cost saving. I'm not going to say anything too much about this slide. I can't say anything, but I'm just going to show you it. And let's just quickly look at a typical architecture. So being an architect, I like looking at architectures, not house architectures, something useful. So we can see here, just a quick thing, let's follow the data path. So all our data sources, we ingest either via ADF, Azure Data Factory, or Synapse, okay? Or you can use Databricks, depending on what you want to do, how you perceive this. I would say these are the two easiest of the ones, because with Databricks, there's the autoloader functionality, and I'll explain that in a bit. But I would always suggest we start with those two to land in our bronze layer. Then we can start our data engineering or our streaming processes to start creating our filtered and clean or augmented layers, okay? And our business aggregates and data models. It's typically like you would have created your data model in a SQL environment. Facts and dimensions. Let's just not talk Data Vault for now. Let's just talk Gimbal, facts and dimensions. You can do that in your gold layer as well. Very similar like you would do. Only thing is now it lives within your data lake. And now you can put in either Databricks SQL or any Power BI tools on top of that using Databricks SQL, okay? Similar process. Here, in between the bronze and the silver, something I haven't mentioned, very specific reason, which I'm going to mention now. Databricks has now something called the autoloader, okay? Very nice technology. So what it does is you can tell autoloader to monitor any changes in the bronze layer, okay? Once it's noticed that ADF has landed something in bronze, autoloader Databricks will pick it up, process it, do whatever you want to do with it. Delete it, sum it, average it, whatever you want content. Autoloader will keep that. So you just actually switch on that job and it'll just keep listening, okay? And it autoloads the whole process. Really nice way. So it manages the change for you. So it doesn't reload your entire bronze layer every time. So remember, bronze can become really big really quickly. Okay. So you don't want to process the entire bronze layer every time. Okay. So everybody with me on that one. So let's say pocket. So we have data coming in to ADF, could be IoT devices, everything. ADF and or Synapse pipelines lands it as POC files in the bronze layer. Okay, so that's the important thing, is to land it as a POC file. Autoloader notices in the metadata store of the POCs that there's a change being made. It looks for the change and processes the change for us. Okay. Any questions on this for now? Okay. So why do we want to use this technology? What is the benefit? I'm just going to do this so then I don't say anything I'm supposed to be saying, but we can obviously see what the benefits are here from a monetary value actually. Price per value, it's very difficult to beat Azure Databricks. Okay. Now, let's have a look at what this is. What are we looking for at time? I tend to run. We still have some for some demos. Okay, guys, so let's have a look at what's going on. Okay, so bear with me. Let's stop the presentation. Okay. So I have my Azure environment. We work in resource groups. So I have created this one yesterday. All it has is a data lake, okay, and a Gen 2 Databricks resource and a key vault. Okay, what's the purpose of a key vault? Exactly what it says. Stores your keys for authentication purposes. Easy as that. Why is that important? Because we do not type passwords in notebooks. Okay, I know it's the easier option. How do I hide this thingy at the top quickly? Sorry, guys, like I said, So within Databricks, the other thing, which I'm not going to show you now, is you saw the key vault. Okay, you can tell Databricks that you have a key vault. Okay, you authenticate against your key vault via a service principal, and Databricks knows what's happening in your key vault. So then you can do secret. You can pull the keys from your key vault. It's all redacted. So if you do print or whatever the other, it won't print the actual password for you. So it's still secure. All keys, tokens, SAS, whatever, it is secure. So that's why the key vault is important. So now let's have a look. So this is Azure Databricks web interface. Okay. So we're going to have a quick walk around here on the side. So you can see here we have a little drop down here, and it changes the look and feel, depends on who you are. So it has what they refer to as personas. Okay. So the first one is your data scientist, data engineer persona. So everything you see is built around that persona. Then we have our machine learning personas, which we might cycle back to in the future, and then our SQL persona. Depending on where you are on your journey, you select the persona you are. I'm going to start with the data science persona for now. Okay. And now you have a workspace. Okay. You can have shared or users. This is mine. I can share it securely with people within my team. You can even go as far to say somebody has read or write privileges on a notebook or whatever. Okay. So if you just want somebody to be able to curate your notebook, for example, but not change code, you can say, fine, they have the ability to comment on your code, but not modify your code even, okay? So let's go to the first part. So quick start, okay? Who's not familiar with the concept of a notebook? I don't have to go into that. Who has never worked in a notebook? I'm not referring the one like paper notebooks. I'm referring to this notebook. I'm going to assume most of you know notebooks. So this is our notebook view. You can see it looks very much like Jupyter, okay? Very similar feel, look, and feel. I have executable cells with markup language abilities to it, okay? But one thing you would note, right at the top here, it says BBD demo cluster. So I've created this. It's take a bit of time to spin up a cluster. If you think about it, if you've ever done Spark installations on-prem and you've gone through that process before, I really feel for you. I do. I've already done this, but let's quickly have a look. So easy, create compute. Okay, so I'm just going to quickly show you. Choose your runtime. It's always good to decide what runtime you want to use because this is based on conflicts in either your Python libraries or Spark libraries or whatever you want to use. So if something's been developed, you need to make very sure what runtime you look. There's the ML runtime, then there's GPUs. So that means TensorFlow has been installed on the cluster to work on GPUs natively. You don't have to go through that process either, okay? But obviously, if you're not going to use that ability, don't spin it up for the sake of just spinning it up and saying it, okay? Use what is required because obviously installing TensorFlow, getting the GPUs provision takes a bit of time on the startup. It's a bit of a process. So choose your runtime. Standard ones are fine. Now, like I said, you have your worker type and then your how many workers you want to have. So 2 to whatever you want to do. I think 160 is the max you can have, okay? Now you can choose the level, the type of server it should be based on memory and cores, okay? So way in the beginning when Databricks first landed, everybody was very concerned about this whole idea of multiple servers. So what most people did is they spun up one cluster, one server. So it does the driver, worker, does everything, okay? And they didn't see any performance benefit. They wondered why. Okay, it doesn't work like that. To get the benefits of Databricks, you need multiple workers. And when I was working with the guys of Databricks, they said, it's always to have more workers, smaller in terms of memory and cores, but more is always better, okay? So think about it. They always say if less is more, so just imagine how much more would be, okay? Then you can decide your driver. What does your driver node look like in terms of memory? This becomes where I said, remember when I said when the data engineering part versus the SQL part, where it becomes a bit more complex. Because this all depends on your reads and writes, your shuffling, but I'm not going to go into that. You need to understand the DAGs for Databricks and all, Spark and all that, but that we can deal with at another time. So this becomes a bit more focused to set up an optimal cluster depending on your workloads. Then also auto-scaling. This is for the minimum and maximum. So it decides like, okay, maybe it needs more and it goes to your max. Termination, like I said, activities, I've just made it 120 so it doesn't time out for now. And then you can have advanced options as well. So if you want to add additional Spark scenarios, jars or stuff like that, or environmental variables, init scripts, whatever you want to do, that all has based on that. You can do that as well. I've already created this one, which is running, so we can quickly have a look at it. So we can see here, this is running 2 to 4 workers. There we have the memories, cores available, driver node, and what runtime I'm running on it, so we can see that. Another big thing with Databricks, if you've ever worked in Python or you know, we're very dependent on our libraries. So let's say there's a library, very specific library you want to use, and you want to install it on your cluster. You click on the tool, install new, you click on Py, and you search for the library you want to do, and you click install. So don't have to even stress about that portion as well, okay? So it'll deal with that for you as well. Okay, now let's go back to the quick start notebook for us. Okay, so what I've done here is you can see here my notebook right up top there where my mouse is. It's a Python notebook, but I've decided to create a table. So this is just a training data set that Databricks provides when you create your resource, so you can have a play around with it. So it's basically located there, but I've decided to say create table using the CSVs, and I've decided to do it in SQL, and I just hit Shift Enter and it runs that, okay? You'll see it's running. Okay. You can see here what's doing. So it's dropping the table. So obviously I've done that before and I've not told it to not drop. Okay. So that's one thing to note. We can see here the Spark jobs running. So if we do here view, we can actually go down to the Spark level details to actually see how things are performing. But I'm not going to go too much view into that. That becomes very, very detailed, and I don't think we have time for that. Now we've registered that table. So you saw it still has a CSV, but I've created a SQL-like table, and I can query it like SQL, okay? So that's running down here. The next one, now for some bizarre reason, I've decided now I want to work in Python in the same notebook. So all I do is I flag the cell as a Python cell. So now I can tell Databricks execute this as Python. Okay, so I'm reading it into a Spark data frame. So Spark data frames are different than Pandas data frames. Okay, so please remember, if you're using Databricks, you cannot utilize a Pandas data frame and expect it to perform. Okay, why? Pandas is not distributed. You can, but it's really not worth doing the effort. Read it into a Spark, PySpark data frame rather, okay? And very similar, we run it and it executes a Python scenario, okay? One last thing I'm gonna show you on this one is the one below. So I've run this for us so we don't have to run through that process again. We can see here, it shows me a bar graph, but I can choose to add it to a dashboard, or I can edit the visualization to say, look, show it in a different format. So I don't even need to write code. If I would like to add a visualization, I can add this by click of a button to a dashboard, okay? But these dashboards are not, this is not for BI. I would not use this dashboard for BI purposes. This is more for your internal teams review and stuff like that, okay? So now let's quickly have a look at the Delta Lake I've shown you. So I spoke a lot about that. I told you it is very important to get the Lakehouse architecture ready. So how do we get something into a Delta Lake format? Okay, so I'm going to show you here how it is, but I think I actually did it on the previous one. Let me show you another one. It's going to be much easier. Okay. So to get something into Delta format, it was, oh, where was that? Oh, no. There. That's it. That is the process of getting something into a Delta format. Okay. So either being a SQL table, we can do this here as well. We'll have a look at that now. Or we can use it in Python and we just tell it, please make sure this is in type Delta. And Databricks will even tell you if you're working on either a SQL table, Databricks table, or a PySpark data frame, it'll tell you this is not Delta formatted, considering reformatting to Delta, and it'll show you how, because it knows it's going to actually increase your performance. Okay. So let's quickly look into this one. I'm not going to run everything for now. So I just want to quickly show you some of the scenarios here. So remember I said there, okay. maybe let's do this and we can quickly have a look at this. Note, it's still connected to the same cluster. You always have to be connected to a cluster if you're going to use the data engineering notebook portions or ML portions. Won't do anything if it's not associated. Okay, so here, this is just a bit of helper function. So I'm just writing a quick Python function to simulate a stream. Okay, this is just helper functions. So please don't worry too much. Note here, percentage %sh. So in this mkdir wget, those of you have ever used a Unix environment, this would look very familiar. That's a shell command. I can even execute shell commands via notebooks on the cluster. Okay, you can't do sudo. It's not going to allow you to do anything sudo based. So for users that not familiar with the Unix environment, that's like Windows administrator level type stuff. It's not going to allow that level of control. It'll tell you you do not have root permissions. Okay, doesn't mean you cannot eat a carrot. Just means you can't access the root of Databricks. Okay, so we can see here. I'm not going to read. I'll share the notebooks with everybody. So, I'll share the notebooks. I'll find a way to share it. You guys can have a look at it. Okay. So now we can see here, this is where the Parquet path lies. I'm reading to a data frame. I'm just doing a delta format of the file. So I'm just doing an overwrite, so it doesn't do an append, and saving it as loans delta. So now I know it's a delta table. Okay. Similar process here. So create loans delta to using delta. And that's the SQL way of doing it. Very easy. It's not that complicated to get something into a delta format. Okay. It is actually very simple. So there's no excuse to not do it. I've not said anything that is, in my opinion, excuse for you guys to not start using Azure Databricks after today. It was just a hint, a sales hint, by the way, if you didn't catch it. Okay, so let's just quickly verify that everything is going. So we're doing a convert on this one. Let's have a look what's doing here. So we can see here what I've done here is, there we go, Spark SQL. So now I've decided I'm going to be very, very, what's the word, masochistic, masochist. Yeah. So I'm going to use Python, but then I'm going to write SQL in a string format just because I like to make my life difficult for myself. So we can see here exactly what happens in terms of that. But we can see here now I have my delta loads running on my delta tables. Okay. And this one is the one I want to show you actually. So here we're doing stream query A. So generating and appending data to stream, table format. Okay. So this is using those helper functions I used up top. So there we can see now it's initializing the streaming functionality. And we can see here based on it, input versus processing and batch duration on data coming in and out on the stream process. Obviously, you won't monitor this in production unless you have really nothing to do for the day. You can sit and watch these graphs. Generally, we don't have time for that, but that's up to you. If you do have time to watch this, I would suggest don't tell your manager about it. And we can see how data is moving in and out of the stream itself. And we can even read the stream, okay? So again, initializing the stream. So I'm just waiting for that one to come up. Hi, whoever joined us online. I don't know if you intended to, but you did switch on your camera, so just be aware of it. Thank you. There we go. So now you can see here, it is already starting to display, and it's showing us a visual, and this is a real-time visual. I can hit refresh now, and the visual update based on the new data flowing into the real-time stream. Okay, obviously I've faked it. Okay, it's not an IoT device. I just didn't have the time to set that up, but similar process. Now I'll show you how that actually works in a bit. We're not going to go through that. I want to show you something else, and I don't want to rush into our lunchtime. Okay, so you guys can see here, there's a lot of capabilities regarding this. Okay, so how would this look in a productionized environment? So how would we go about and creating this into a production-based environment? So I have this here. So if we quickly look here, you can see here, I have a whole bunch of notebooks. So here is my first notebook. This basically, so I've redacted some of it for specific reasons. So we can see here, remember what I said, we don't type passwords. So if we said DB utils, so Databricks utils, .secret.get, and the scope is what you've defined. And now you can say, look, go to Key Vault, find this key, and actually note that. Okay, so this first port only creates the keys and accesses and mounts the different spaces for us. Okay, now we can go to, let's do this one first. Yeah, so these notebooks, or these notebooks that I've actually shown you here, actually deals with this exact architecture. Okay, so this is what we're trying to achieve here. We're landing IoT devices from IoT Hub via Data Factory into the Parquet landing zone. We're using Autoloader to actually process that and land it into a curated Delta Lake. Okay, here I'm doing the autoloaders config. I'm not going to go too much detail into this. I just want to show you actually what the process will look like from it. And I'm not going to run everything. It does take a bit of time for this one to do. So we can see here, we can write our streams or read our streams. So you can write real time as well to your data lake. Okay, we have all that via autoloader functionalities. Here we have creating our Delta tables so that we can query it by SQL. And then we can go back and say, look, here is the streaming port for IoT Hub. There's the silver serving the gold layer as well. So we want to have a look at what that looks like. So we can see here, it actually reads from the silver layer, either via batch and streaming, and it creates the gold. And there we have a SQL function that actually processes the data from the silver layer into the gold layer so that it becomes, let's say, BI ready. Okay, so you can see what everything looks like. Okay, so we have a few minutes left. So something else I want to quickly show you is the SQL portion of it. So now let's jump to the SQL persona. So if I click here, you'll see things are going to change a bit. So things look a bit different now. So now we have a SQL editor available to us. Okay, so if we look here on the side, this is the diamond table I registered. Remember the first part thing I did for us, the quick start, there was the diamonds table we created. There we have the diamonds. Now we can have a look at that, and we can write our queries on top of that. So here I have a query for that. It's running against the serverless, and we can see here it actually does a graph as well for us. Okay, and we can do it against any table we've registered. So if you look at the meta store, so how Databricks is, let's say, structure works, you have your meta store, then your catalogs, then your schemas, then your tables. Okay, so sample has quite a lot of nice things to look at for us as well. It's just loading a bit. This one you will utilize, I think it's this one here, which I wrote for us. So anybody familiar with the NYC taxi database? So it's in here for us as well. And you can actually write SQL on top of the NYC taxi database, which was obviously registered as a Databricks table, which we are now querying via SQL. Okay. Dashboards as well. That thing's taking a bit long. I just want to show you the dashboarding functionality. So this is different from the dashboarding I showed you in the engineering part. Okay. So I'm going to show you this one. You can see here, this is on top of that taxi database. You can see here, based on that, and you can click on this visual. Just see, find one. You can click on it. You can see preview visualization, and you click view query. So if you are looking at a dashboard and you want to see what the query was that somebody wrote to create that visual, you just say view query, and it actually shows you the query that was actually used to create that visual. Okay, so you don't need to blindly trust visuals anymore. If you don't, you can actually have a look at the query. Obviously, business users won't do this. This is when you go through your UAT cycle for visualizations. Okay. Now, one other thing. So server data, SQL data servers. So I said here we have the serverless one. You can see here it is t-shirt sizing. Okay. So small, medium, large, so that we don't have to deal with that same principles we had to deal with when it comes to the Spark servers clusters. Okay. Same print, but more easier here to do this. And what is quite nice of this is if I click on the serverless function, if I click on monitoring, I can actually see the processes. I can see what's happening here. I can even see here, show query history, what queries have been run against this serverless SQL of mine as well. Okay, so while this one loads, there we go. You can see here everything that has ran against this SQL query. If I go down here somewhere, I think this was quite early this morning. I just tested something. This here actually is related to a Power BI report I created connecting to this serverless SQL. So how did I go about doing that? Actually, well, that was actually quite difficult. So I'm going to quickly show you. So bear with me. That is actually a bit of a painful exercise. So you go to your SQL warehouse, you click on the one, you click on connection details, you scroll down, you click on Power BI, and you say download a Power BI template. And that has all the connections in it for you as well. So I have done that. So let me just quickly open it for you. Come on, you can do it. I want to say my laptop would be faster if I did it via Teams, but that might not be appropriate. So guys, I just want to open Power BI just to prove it to you. So that's how easy it is to actually get to your serverless SQL to Power BI to building reports. And remember, this is data that is living in the data lake. Okay, it's not living in anywhere else. It's literally data lake data that I'm querying via this. Obviously, it goes via the Databricks SQL server, which goes and fetches it in an optimized way from the data lake. Okay. Who's never seen Power BI before? Shame on you. Just waiting for establishing connection, and it'll show us everything we have related to our. Come on, you can do it. There we go. Oh, there we go. Hive, sample data, same principle, and you can access that tables by the Power BI to start building your reports. Okay. On that note, I am done. Any questions? You can ask Sully. Yes, we have there in somewhere else.
Sorry, you mentioned before about the data like kind of keeping like metadata on its old versions.
Yes, yes,
Like
yes.
sorry, can you like elaborate on that? So,
Yeah, I can actually. So what it basically, well, I think it would be better if I just show you something actually quickly. So if I go back to, everybody see, there we go. Come on. So now we're going to jump back to my data engineering persona because that's where that functionality lives. So if we go back here to my workspace, okay, it would be diving into Delta Lake. So what happens is every time you make a modification to your Delta Lake, it actually stores the changes in the meta store for you, okay? So what that means is you can go and say, look, please have a look at the meta store. Let's see here where time travel is. I'm quite sure I did do something on that. Insert update. There we go. So you can see here. Where is that? It's somewhere here. I did something on me. Just quickly find that out. Anyway, I don't see that now. So what it does is if you make a change to the Delta Lake, so if you do an insert, an update, append, it actually goes and says, look, this is what the data looked like, what was the data before, and this is what's been done. So you can actually see the code that actually ran, if it was an append, an insert. So you can actually filter and say, look, show me on that data table what insert statements, what update statements, what merge statements were occurred. So you can do it. You can filter that catalog actually with SQL, and it actually literally shows you what's been changed to that data set. Okay. If for some reason you would like to go back a step, so each change is versioned, and you can call a version if you would like to, okay? And you can say, look, please use this version of the data rather than the latest version. Or for auditing purposes, maybe you are working with data that needs to be audited. So you need to do a report on what changes have been made to the data. You can export the metadata history of that table and give it to the auditor, say, look, this is what's been done to the data. Here you can see everything and so forth. So that is what I mean by time travel. So you can actually jump between different versions of the data and you can see what's happening. Okay.
Okay. Are you in control of that? Like, can you say increase the level that you're saving? So like, can you say like maybe don't save the copies of selects, of inserts, but like
no.
save
So unfortunately, you can't say if somebody does a so if you're doing a project XRs and you want to delete your ID because they don't want to do it for you, you can't say, okay, if I'm writing a SQL statement to remove myself, don't log it against the history, not going to work. It logs everything. It's part of the Delta. You have no control to say, don't do this, don't log this, don't log that. No, it'll log everything.
So kind of like Git, basically.
Sorry?
Kind of like Git. GitHub, like Git.
No,
not like Git.
No.
Okay.
No, it's not. It's not versioning control. Although it does version, it's not versioning controlled. Okay. It's like part of the meta store. Okay. So don't think of it as like a GitHub version control of data. It's a bit different than that. It is for audit trail and so sometimes for machine learning models. So you might want to work on a specific version of the data set for your machine learning models. You don't want to work on the latest one for specific reasons. Who knows? Maybe there's been a bit of data drift and you haven't accounted for that data drift in your model yet. So you would rather work on that version than the other versions and so forth. Okay. There was another question somewhere.
So with the suite provided by Azure Databricks, why would a customer use Databricks over the Synapse sort of suite of tools?
That's an interesting question. In my opinion, it's personal preference. So firstly, it depends on what your output needs to be. Okay. So if we were from the endpoint, if your goal, well, it's not truly true because Databricks can actually write to Synapse SQL warehouses since, I think, 3 weeks ago. There's the ability to write to the Synapse SQL warehouse as well. But it all depends on, firstly, personal preference, commitment to a specific technology and skills. Okay. So the one thing with Synapse, which makes it a bit more easier, is Synapse has data flows and pipelines, and you can choose. You can either do it graphically, so nice little blocks, click and drag. Although you can do it in Databricks, I didn't show you, but that only links specific notebooks, so you still have to write a bit of code. Synapse has a pure no-code type interface, or you can go Polybase SQL as well. So it depends on where you want to be in terms of a skill set level. The other thing is optimizing Spark workloads is not trivial. You need to have a look at what's happening. Otherwise, you might over spec or under spec, and you're not going to get performance. So that's the other thing. In terms of, I would say, enterprise versus SMCs, it's a big difficulty. So I'm not saying Synapse is bad, quite the opposite. Distributed SQL is very powerful, especially if you have a lot of reports hitting your SQL database. That is where Synapse becomes really valuable, the dedicated SQL pools. But let's say it's a smallish SMC that does not have capacity for Synapse. They don't have even 500 gigs of data to put in a warehouse. I don't see Synapse SQL being the right play for them. But my Databricks SQL might be a correct thing for them. If they're actually starting their analytical journey, they don't know if they want to invest that much. Okay. So Synapse, we generally tell people you start off, you do pay as you go, and then you commit once you actually know, because that is when it becomes a bit cheaper. With Databricks, it's not that big of an impact. You can still see. I hope that answers. Somewhere, yeah.
That actually leads quite nicely into the question I had, which was about how billing works for this thing. Like, what are you charged for?
I charge nothing. It's all based on the Azure billing, so I don't ask.
Oh, okay.
No, so it's a bit. So in terms of, if we look at Databricks, you pay for compute. Okay, so it all runs on compute. So you pay per second compute, and you can go check the pricing for that. And there is something called the Databricks unit, so DBU. You'll always see when you're doing your Databricks costing, there's two portions of it, the compute portion and the DBU portion. So the Databricks DBU portion is what we as Microsoft give to Databricks to help them actually grow their business and develop new things for us, okay? The other portion of it is the compute you use that we actually are utilizing in our data centers. But I must be honest, with Databricks, you can actually come quite far with a few $100. Synapse has costed a bit more different. So Synapse, you pay for your SQL warehouse, and that we have what we refer to as DW units. So it goes from 100 to 3,000. And that's a mix of capacity in terms of CPU power, IO, and memory, and also distribution. So anything from 100 to 500 DWs isn't actually distributed across different nodes. It's only when you get 1,000, then it starts distributing and so forth. But then that's the SQL portion. Then you have to actually go and say, from the pipeline portion, that is costed differently, because the interesting thing is Synapse pipelines actually also execute against Spark. So then you pay for the compute that pipeline will use to execute. You have control over the pipelines as well. So you could say, look, don't go beyond this tier or something like that. But you have to be, I would say, a bit more careful in terms of when you're constructing your pipeline. I've seen people with runaway costs because they don't realize what happens when you actually build a pipeline. So remember, pipeline is a visual thing. So what Microsoft says, you want ease of use, you will manage the rest. You just want ease of use and you want performance, okay? So it actually just does everything in its power to make sure your pipeline executes as quick as possible. If that means spinning up 1,000 Spark nodes, it'll do that. Especially if you're not thinking about how you're structuring it. It's not going to do that every time, but you need to think about that. There's still, with everything we do, you still need to use a bit of brain power, unfortunately. We can't do everything. So for Databricks, the dashboarding built in, you pay for that SQL server, again, the compute used for the SQL server. The dashboarding side is just part of the package. Power BI obviously is a licensing model on its own.
Any more questions? Nothing? Thank you so much for coming to talk to us. We really enjoyed your talk, and I'm sure we all learned a lot. So thank you.
Thank you. Next time, let's do what? ML, ChatGPT. What are we looking at next time? Sounds good. We'll do OpenAI. Cool, guys. Thank you. Thanks, everybody online.